This one asks you to find the fifth term in the expansion of this thing. So there's two ways to do it. If you want to just expand the whole thing like we did before and then simplify just the fifth term, that's okay. And that's actually probably not that hard to do in this case. But there is a formula that you can use, and it's here. It's also on your formula sheet for the exam. T k plus 1 equals n choose k, x to the power of n minus k, y to the power of k. So we need to kind of look at what those things mean. T just stands for term, so you're finding the term of k plus 1. So what that means, if we're trying to find the fifth term, we want to find T5. So I'm going to put that down. We'll do this first. Move that over there. And let's just make a note of some of these things. T equals term. K is actually one less than the term number, which is a little weird, but it means if you're trying to find the fifth term, then k is 4. If you're trying to find the eighth term, then k is 7. It's one less than whatever term you're trying to find. N is the exponent. So in this case, 8. And then we have x and y. X is the first term of the binomial. And y is the second term of the binomial. For this particular question, we're trying to find the fifth term. So T is a question mark. That's what we're trying to find. What is K in this one? 4. It's one less than the term number, and we're trying to find the fifth term. So 1 less than 5 is 4. What's N? 8. It's that exponent. What's X? 3a cubed. And what's Y? Negative 2b squared. So then I'm just going to fill everything in to the formula. So I'm going to say T5 is equal to 8 choose 4. 3a cubed to the power of 8 minus 4 and negative 2b squared to the power of 4. Just once you figure out what all the numbers are, then just fill them in. Then we can start simplifying. 8 choose 4 is 70. And then it's 3 to the power of 4, because 8 minus 4 is 4. 3 to the power of 4 is 81. A cubed to the power of 4 is a to the power of 12. And then negative 2 to the power of 4 is positive 16. B squared to the power of 4 is b to the power of 8. When we do all that multiplying, we end up with 90,720 a to the power of 12, b to the power of 8. And that's the answer. That would be, if you expanded that whole thing, the 3a cubed minus 2b squared to the power of 8, the fifth term that you got in the expansion would be that, 90,720 a to the power of 12, b to the power of 8. Here's the next one. In the expansion of 4a cubed plus 3b cubed to the power of 5, what is the coefficient of the term containing b to the power of 12? That's a little bit more of a tricky question instead of just straight find a particular term. It's asking us for the coefficient of the term, so it's basically asking us for the term. So we don't know what t is. The problem is we also don't know what k is. And so we're going to have to somehow figure that out. We do know n. That's 5. We do know x. That's 4a cubed. And we know y. 3b cubed. So what I'm going to do is just take that formula and fill in the stuff that I do know. I'm trying to find t k plus 1. I don't know what k is. So I'm just going to do 5 choose k. And then I'll put in the 4a cubed to the power of 5 minus k. I think I need to move that down a little bit. I don't have enough space. This is just everything that I know filled in. The problem here is I only have one equation, but I have two unknowns. So I'm going to need to figure out that other unknown value somehow. So if I go back to the question, it's asking for the term containing a b to the power of 12. Well, what we have is a b to the power of 3 to the power of k, and I need that to equal b to the power of 12. So I'm just going to put that here. B to the power of 3 to the power of k has to equal b to the power of 12. That's what I get from the question. What is k equal to? K is equal to 4. You can just kind of figure that out by inspection, by looking at it, or you could try to actually solve this equation, which wouldn't be that bad. You do, really what you're doing, b to the power of 3k equals b to the power of 12, so 3k equals 12, and k equals 4. But now I can go back and change all those k's into 4s. So it's actually t4 plus 1 equals 5, choose 4, 4a cubed to the power of 5 minus 4, and 3b cubed to the power of 4. Now it's just a matter of simplifying it. The tricky part is sometimes figuring out what k is. But I find once I fill all that in and look at, okay, where is the b, what do I have, then usually finding k isn't that bad once you have it all filled in. So now I'll just simplify some of this. 5 choose 4. So it's actually the fifth term that we're finding. 5 choose 4 is 5. 4a cubed to the power of, that's actually just a 1, right? 5 minus 4, so that's just 4a cubed. And 3b cubed to the power of 4, that's 81 b to the power of 12. And when you multiply that out, 1,620 a cubed b to the power of 12. That term has a b to the power of 12 in it. That's what we wanted. The coefficient is 1,620. That's what it's asking you for. So it's really just asking you for that number there. In the expansion of 2x squared minus 1 over x to the power of 6, what is the constant term? So it's asking you for a term that doesn't have a variable in it. So again, we don't know k, which is the problem here. Is first to figure out k and then to figure out the term. So again, t is a question mark, but right now k is also a question mark. And it's going to be a little bit trickier to figure out k in this one than it was in the previous question. But we do know n, that's 6. And we know x is 2x squared. And y is negative 1 over x. Make sure you keep that sign with the with the y, like I said before. And again, I'm going to start just by filling in what I know. So tk plus 1 equals 6, choose k, and then 2x squared to the power of 6 minus k, negative 1 over x to the power of k. So what I did next, or what I'm going to do next, is try to simplify what I have here. So tk plus 1, 6 choose k, there's really nothing I can do with that. But I'm going to separate the 2 from the x squared in the next term. So I'm going to do 2 to the power of 6 minus k, and x squared to the power of 6 minus k. And then I'll do the same thing. Well, I'll do this one like this. Negative 1 to the power of k over x to the power of k. So just separating the negative 1 and the x that way. Now I want to put the x's together. So I end up with this, still 6 choose k, 2 to the power of 6 minus k, and I'll put the negative 1 here, negative 1 to the power of k. And then for the x's, what I have, x squared to the power of 6 minus k, I simplified that to be x to the power of 12 minus 2k, and then I put this over x to the power of k. Let's make this 6 choose k, 2 to the power of 6 minus k, negative 1 to the power of k, and I'm going to simplify that x as much as I can. What do I do with the exponents when I'm dividing x's? Subtract, right? So it's going to be x to the power of 12 minus 2k minus k, which is 12 minus 3k. Is that what you said? Yep, 12 minus 3k. Now we're getting to something that we can work with. 12 minus 3k has to be equal to 0 for it to be a constant term. So k is 4, right? 12 minus 3k has to equal 0. Solve that for k, you get k equals 4. Now you can figure out what this term is going to be. We're looking for the fifth term. So we're going to do 6 choose 4 times 2 to the power of 6 minus 4 times negative 1 to the power of 4 times x to the power of 0, which is just 1. 6 choose 4 is 15 times 2 to the power of 2, so 16 times 4. And then negative 1 to the power of 4 is 1. X to the power of 0 is 1. So it really is just 15 times 4. So the answer is 60.